In our lesson today, we're going to look at the distributive property and see how the distributive property will allow us to create equivalent algebraic expressions. It is important to know how the properties of numbers, and it's important to know how to use the properties of numbers in order to produce equivalent algebraic expressions. In our last lesson, we saw how we use the commutative property in order to make simplifying an expression easier. Today, we're going to focus on using the distributive property to help generate equivalent algebraic expressions. And here in the box, we're going to review the distributive property. They tell us that if A, B, and C are numbers, then A times in parentheses B plus C can be rewritten as A times B plus A times C. All right, the term that's on the outside is going to multiply each term that's on the inside, and then we can add them together. The distributive property also works for subtraction. Again, if I have A, B, and C as my numbers, A times B minus C in parentheses is the same as doing A times B minus A times C. And you use distributive property in earlier grades to help you with multiplication. In our first example, it says to use the distributive property two different ways to calculate the product of 3 times 47. We all know the algorithm in order to do the multiplication of 3 times 47, but we're going to show how to make it a little easier by breaking 47 up two different ways. 47 can be written as the sum of 40 plus 7, or 47 can be written as the difference of 50 minus 3. We're going to show that 3 multiplying that sum and that difference will give us the answer to 3 times 47. So by using the distributive property in the first example, where it's using addition 40 plus 7 in the parentheses, we're going to take the 3 that's on the outside and multiply it by both of the numbers that are on the inside and then add them together. So we're going to do 3 times 40, and then we're going to do 3 times 7, and the answer to that we're going to add together. 3 times 40 gives us 120. 3 times 7 gives us 21. And when we add those together, we get an answer of 141. Okay? Since 47 is also the same as 50 minus 3, when I use the distributive property here, I should also get 141. So again, the term that's on the outside is going to multiply each term that's on the inside. So we're going to start by doing 3 times 50. And now this 3 is positive, so I'm going to write plus 3 times this 3 is negative, so I'm going to write negative 3. All right, 50 times 3 here is 150. Positive 3 times negative 3 is negative 9. So we're going to have 150 minus 9, which again gives us 141. So using the distributive property, I have two equivalent answers. And then again, you can check with the algorithm itself. 47 times 3. 7 times 3 is 21. 4 times 3 is 12. Add 2 is 14. And there it is again. We get 141 as our answer. So we just had a good review up above about how to use the distributive property in order to help us find the answer to a multiplication problem. All right. Now, we could also have used the order of operations in each of these cases by evaluating the parentheses first and then doing the multiplication, which again, either way would have given us this middle part here of 47 times 3. Well, the distributive property is often used when variables are involved. All right. For example, right here, I have 9 multiplying 2n plus 3. Now, if I wanted to follow order of operations and evaluate what's in the parentheses, I actually wouldn't be able to do anything here because 2n is a variable term and 3 is a constant, and you can't combine a variable term with a constant. So what I'm going to do here is use the distributive property to generate an equivalent expression for 9 times 2n plus 3. Once again, the number that's on the outside is going to multiply each term that's on the inside. So to use the distributive property here, I'm first going to do 9 times 2n, 9 times 2n, and then I'm going to do 9 times positive 3. So that's a positive 9 times the positive 3. And now when I do the multiplication for each part here, I'm going to get a new equivalent algebraic expression. 9 times 2n is 18n, and 9 times 3 is positive 27. So 9 multiplying 2n plus 3 in parentheses is equivalent to doing 18n plus 27. Now, once again, I'm going to show that these two are equivalent to each other by using a value for n. If n equals 4, we're going to use the order of operations to show that the expressions are equal. So on one side, we're going to do 9 times 2n plus 3. And on the other side, we're going to do 18n plus 27. And if these two are really the same, we should get the same answer when we substitute in the value of 4 for n. So let's do that over here on the left first. We're going to have 9 times 2 times 4 plus 3 in the parentheses. We have to do the multiplication inside first. 2 times 4 is 8. So we have 9 times in parentheses 8 plus 3. Now when we add 8 and 3, that gives us 11. So we have 9 times 11, which gives us an answer of 99. Hopefully I get the same thing over here. Once again, n has a value of 4, so we're going to have 18 times 4 plus 27. If you do 18 times 4, that gives you a value of 72. And now when we add 72 and 27, once again, we get 99. So this has proven that the original expression is equivalent to 18n plus 27 after we use the distributive property. In examples 2 through 4, what we're going to do is take each algebraic expression and use the distributive property to generate an equivalent algebraic expression, similar to what we did up here. Okay, so again, we're going to take the number that's on the outside and we're going to multiply it by each term that's on the inside for each one of these examples. So starting with example number 2, we have 3 multiplying x plus 7 in the parentheses. Remember that x is the same as 1x, so you can put a 1 there if you would like. And when we distribute, that's going to say 3 times 1x plus 3 times 7. Okay, that's a positive 3, so we wrote plus 3 there. Now, when we do the multiplication, 3 times 1x is 3x, and 3 times 7 is a positive 21. So the equivalent expression would be 3x plus 21. In example 3, notice that there are 3 terms in the parentheses. The 9 is going to multiply each one of those. So we're going to have 9 times a, which is the same as 1a. Then again, this 9 is positive, so we're going to write plus 9 times. The middle term is a negative 3b. So I'm going to put negative 3b times 9 there. And then again, positive 9, so plus 9 times, that's a positive 11. Now when we do each part of the multiplication, 9 times 1a is 9a. 9 times negative 3b is negative 27b, so we write minus 27b. And then 9 times 11 is positive 99, so we're going to write plus 99. A's are different than b's. Variable terms can't combine with constants. That is your new equivalent expression. In example number 4, we have 7 multiplying in parentheses 5x plus 8. So once again, this 7 is going to multiply each term inside. So we'll start with 7 times 5x, and then plus 7 times the 8. That's a positive 7, so we write plus 7. Now, 7 times 5x is going to give me 35x, and 7 times 8 is a positive 56. So the equivalent expression is 35x plus 56. In each example that we've looked at so far, the number that we've distributed was positive. So let's take a look at an example where the number getting distributed is a negative number. Make sure that you pay attention to your signs. Okay, so for example number 5, we're going to write an equivalent expression for negative 2 times 3x minus 4 using the distributive property. Again, the number that's getting distributed is a negative number. So we're going to start by writing negative 2 times 3x. And then since that's a negative 2, I'm going to write minus 2 times, that is a negative 4. So I'm going to write times negative 4. Now when I do the multiplication, negative 2 times 3x is negative 6x. And negative 2 times negative 4 is positive 8. So the equivalent expression would end up being negative 6x plus 8. So once again, when you're distributing with a negative number, just make sure that you watch your signs. That's a negative 2, that's a negative 2, and then right here where it says 3x minus 4, that's technically a negative 4. A negative times a negative will give you a positive. In examples 9 through 11, we're going to practice distributing with a negative number. Once again, just make sure that you pay attention to your signs. In example 9, we have negative 6 multiplying 3p minus 5 in the parentheses. So the negative 6 is going to multiply each term. So we're going to start by writing negative 6 times 3p. And then because it's a negative 6, we're going to write minus 6 times, that is a negative 5. When we multiply now, negative 6 times 3p is negative 18p. And negative 6 times negative 5 is positive 30. So the equivalent expression is going to say negative 18p plus 30. In example 10, we have negative 7 multiplying in parentheses negative 6n plus 8. Let's distribute the negative 7. We'll start by writing negative 7 times negative 6n, and then minus 7 times, that's a positive 8. When we multiply, a negative 7 times negative 6n is positive 42n. Negative 7 times 8 is negative 56. So the equivalent expression is 42n minus 56. In example 11, we're distributing negative 9 to 5x plus 2 in the parentheses. So we'll have negative 9 times 5x at the beginning, and then negative 9 times positive 2 at the end. And when we multiply negative 9 times 5x, we get negative 45x. Negative 9 times 2 is negative 18. So we have an equivalent expression of negative 45x minus 18. In our previous examples, we've been distributing a negative number. But what happens when there's a negative number all by itself in front of the parentheses, like in example 12 and in example 13? Okay, when there is a negative by itself on the outside of the parentheses, what integer is being distributed? Well, we've talked about this before. When we see a negative symbol all by itself, that's understood to be the number negative 1. Okay, so in example number 12, where it's negative and then in parentheses 5x plus 8, that's the same as saying negative 1 times 5x plus 8. So I'm really going to be distributing negative 1 to each term inside of the parentheses. So for example 12, I'm going to write negative 1 times 5x, and then minus 1, again, because that's a negative 1, times positive 8. And when we multiply negative 1 times 5x, we get negative 5x. Negative 1 times 8 is negative 8. So the equivalent expression would be negative 5x minus 8. Okay, very similarly in question 13, again, that negative symbol is the number negative 1. So we're going to distribute negative 1 to the negative 9x. And we're going to distribute negative 1 to the negative 12. And then when we multiply, negative 1 times negative 9x is going to give us a positive 9x. Negative 1 times negative 12 is going to be a positive 12. And so our equivalent expression would say 9x plus 12. On page 12, this is where we take the information from the last two classes and put it all together. All right, the directions say to simplify the following expressions, use the distributive property, and then combine like terms. Okay, in order to simplify these expressions, I'm going to have to do what I did last class, where I'm going to have to combine my similar terms. Only this time, notice though, we have parentheses and numbers multiplying those parentheses. So the very first thing that we're going to have to do in each case is use the distributive property. Once we've used the distributive property, we can then rearrange our terms with the commutative property and then combine all similar terms. So looking at example 15, we have 7 times 2n minus 4 plus 6 times negative 3n plus 4. So notice that there are two sets of parentheses. Each set has their own number that's getting multiplied to each term. So we're going to use the distributive property twice. We're going to first multiply 7 by 2n minus 4. Then we're going to multiply 6 by negative 3n plus 4. So let's go ahead and start there. 7 is going to multiply by 2n. Plus 7, because that's a positive 7, is multiplying that negative 4. So that's the first distribution that I had to do. Now I have to distribute with the positive 6. So I'm going to write plus 6 times negative 3n. And then again, plus 6 times the 4. So now I have distributed each term to their respective set of parentheses. When we go ahead and multiply now, 7 times 2n is 14n. 7 times negative 4 is negative 28. 6 times negative 3n is negative 18n. And 6 times 4 is positive 24. So our expression now says 14n minus 28 minus 18n plus 24. We're going to use the commutative property now to get our similar terms together so that we can simplify further. So variable terms will go at the front. I'm going to have 14n minus 18n. Constants will go at the end, minus 28 plus 24. Now I'll go ahead and combine my terms that are similar, starting with the variable terms. 14n minus 18n is negative 4n. Bring down the negative 28 plus 24. And now I can combine my constants. Negative 28 plus 24, they're different signs, so I'll subtract. Negative 28 plus 24, that's going to give me an answer of negative 4. So my next line down is going to say negative 4n minus 4. We have a variable term and a constant, which can't be combined. So this is as simplified as this expression is going to get, negative 4n minus 4.